Hi, in this video I'm going to go through question 33 on IMAT 2012. So this question tells us that there is a regular train service between Jayford and Kayton, and this journey is 16 kilometers and takes 19 minutes. Now the trains travel at 60 kilometers per hour in both directions, except when it goes through a tunnel where they travel at 20 kilometers per hour. We're also told that trains towards Kayton enter the tunnel 4 kilometers after setting off from Jayford, and we want to know how long is the tunnel. Okay, so let's have a picture. So here is my train line from Jayford to Kayton with my tunnel in the middle. And the whole thing is 16 kilometers, which takes 19 minutes. And we're told that the trains travel at 60 kilometers an hour outside the tunnel, and in the tunnel travel at 20 kilometers per hour. So these sections are 60 kilometers per hour and inside is 20. And we're told that when we're travelling towards Kayton, we enter the tunnel 4 kilometers after setting off from Jayford. So this section here, we also know is 4 kilometers. Okay, so we have some speeds, we have some distances, and we have some times. So which equations would we want? Well, it certainly seems that these ones relating the three would be useful. So this is speed equals distance over time, and then rearranged for distance and time. Or maybe you prefer to use the triangle, where we have distance, speed, time, and you just cover up the one you want. So if I wanted speed, I'd cover up speed, and I'd be left with distance over time. Okay, so what do we know, and what would we like to know? So we pretty much know everything we need to know about this first part of the journey between Jayford and the tunnel. So we have a speed and a distance, and then we can use this formula here to work out the time. So let's do that now, actually. So time is distance divided by speed. So that gives us that our time is 4 kilometers divided by 60 kilometers per hour. So that simplifies to 1/15 of an hour. That's a bit awkward to work with, and our other times in minutes. So let's turn this into minutes. So 60 minutes in an hour means that if we multiply by 60, we will get that 1/15 of an hour is the same as 4 minutes. So we have 4 minutes here as well. Okay, so now what do we not know but we might like to know? So we don't know very much about when we're in the tunnel and after the tunnel, between the end of the tunnel and Kayton. So we have some speeds but no distance or times. So in order to work those out, let's say x is the length of my tunnel and y is the distance between the end of the tunnel and Kayton. And now we have some distances, we can also work out some times. So once again, using this formula for time equals distance over speed, we get that the time we spend in the tunnel is going to be x divided by 20, and the time after the tunnel will be y divided by 60. And remember, these times are in hours because our speed was in kilometers per hour. So we'll have to multiply by 60 in order to get the time in minutes. So simplifying, we get that our times are 3x and y. So 3x for the tunnel and y for after the tunnel. Okay, so now we have a distance and a time for each part of our journey. And we also have a total distance and a total time. So how can we put all that together? Well, if we add up our distances, so 4 plus x plus y, that is going to give us our total distance 16, so that gives us one equation. And adding up the times, so 4 plus 3x plus y, is going to be equal to the total time, 19. Okay, so now we've basically got two simultaneous equations for x and y, and we want the length of the tunnel, which is just given by x. So to solve the question, all we have to do is solve these two equations for x. And you can do that any way you want, but I think the easiest way would just be to take one equation from the other. So actually, it probably works better if I take it the other way around. So if we take the distance equation from the time equation, these 4's just cancel and these y's just cancel, so we're left with 2x equals 3, and dividing by 2 gives us that x is 1.5. So the length of this tunnel is 1.5 kilometers, and that gives us our answer C.